Bismillahirrahmanirrahim. Assalamu alaikum, dear student. In today's lecture, we will learn second derivative test. This test is related to find the extrema of a function. We have already learned first derivative test. When first derivative test fails, we use second derivative test to find the extrema of a function. And in addition, we will learn in today's lecture about concavity of a function. So let's start with today's lecture. First of all, I would like to brief about concavity. Uh, if the second derivative f double prime of f exists on open interval I, then the graph of f is concave upward when f double prime of x is greater than 0 on interval I, and concave downward when f double prime of x is less than 0 on I. The interval will be constructed by putting second derivative is equal to 0. Then we will take a test value from the interval and we put in the second derivative. If it is greater than 0, then the function has a concave upward graph, and if it is less than 0, then function will have concave downward graph. This can be demonstrated in terms of a graph. If this function graph of this function is like that, this region would be called concave downward. Uh, if the graph is like this, and then this will be graph is concave upward. Now let's run another definition. Point of inflection: a point c, f of c on the graph of function f is a point of inflection if the following conditions are satisfied. F is continuous at c, uh, and there is an open interval. There is an open interval containing c such that the graph is concave upward on uh, first interval a to c and concave downward on cb, or vice versa. I will clear this concept with the help of this graph. In this function, this is the concave upward graph, and this is concave downward point, concave upward graph. The point at which the function changes behavior from concave downward to concave upward, or concave upward to concave downward, is called point of inflection. This point at which I have put cursor, this is the point of inflection. Uh, and if you see this portion of the graph, this is concave downward and this is concave upward, and at this point at x is equal to minus pi, this is point of inflection. This is point of inflection, and if we see this is a concave upward graph and this is concave downward graph, at this point function changes behavior from concave upward to concave downward. This is point of inflection at x is equal to 0, and x is equal to pi is already demonstrated. Now, second derivative test. Let C be a critical number for f, and suppose that f is a continuous at C and differentiable on open interval I containing C except possibly at C itself. Then f double prime of C is less than 0. Then function f is a local maximum at C. If the second derivative at C is greater than 0, then the function will have local minima at C. This definition will be implemented by first of all we find the critical point. Critical point are found by using a equating derivative. It is equal to 0. Then we will determine the second derivative, and we will put one by one all the critical point in the second derivative. If the second derivative is negative, then the function will have local maximum at that critical point, and if second derivative is greater than 0, then f will have a local minimum at c. Now we proceed toward exercise 3.4. Question 1 to 16. Find the local extrema of f using second derivative test. whenever applicable. Find the interval on which the graph of f is concave upward, or is concave downward, and find the x-coordinate of point of inflection and sketch the graph of f. First of all, we have to find the extrema of a function. This is the question. F of x is equal to x cube minus 2x square plus x plus 1. First of all, we will determine our first derivative and second derivative. This is the first derivative is equal to 3x square minus 4x plus 1. If we differentiate again it with respect to x, we will find the second derivative, which is equal to 6x minus 4. First, we have to find the extrema to using second derivative test. In second derivative, we have to find first the critical numbers. First, for the critical number, we put f prime of c is equal to 0. We will have 3c square minus 4c plus 1 is equal to 0. We factorize it and simplifies it. We will find the value of c is equal to 1 by 3 and 1. Now, in order to find the extrema, we will put these two critical number in equation number 3 uh, to check whether function have a local maxima or minimum. First of all, we have put x is equal to 1 by 3. F double prime of 1 by 3 is equal to 6 into 1 by 3 minus 4. If we simplify this, 3 will cancel with 6. We will have 2. 2 minus 4, which is equal to minus 2 and less than 0. This means that f has a local maximum at c is equal to 1 by 3. In order to find extreme maximum value, put this value in equation number in order to determine the local max. If you put x is equal to 1 by 3, uh, all the calculation are given here. If we simplify this, we will get the value of the local maximum is equal to 31 divided by 27. Now, we will check second critical point, which is c is equal to 1. We will put c is equal to 1 in equation number 3 to determine whether the function has a local max or local minimum at this point. If we put f double prime of c is equal to 1 in f double prime of x, f double prime of 1 is equal to 6 into 1 minus 4, which after simplification we have value 2, which is greater than 0, which signifies that f has a local minima at c is equal to 1. Now, in order to find this local minima, we will put it into equation number 1. F of 1 is equal to 1 minus 2 plus 1, which is equal to 1. This is the local minima of a. Now we will check the concavity. So to check the concavity, we will equate second derivative is equal to 0, so that we will construct with the help of this the intervals of concavity. 6x minus 4 is equal to 0 and x will is equal to 2 by 3, and we have the interval minus 3 minus infinity to 2 by 3 and 2 by 3 to infinity. In order to check whether function is concave upward and downward, we will take a test value from each interval. We have taken 0 from first interval, and we will put this in the second equation number 3 or second derivative. F double prime of 0 is equal to minus 4, which is less than 0, which signifies that function has concave upward graph in this interval. Now we'll check a test value from the second interval. We have taken 2 from second interval 2 by 3 to infinity, and we put this in equation number 3. F double prime of 2 is equal to 6 into 2 minus 4, which after simplification we have 8, which is greater than 0, which signifies that in second interval function has a concave upward graph. This is the uh, concave up. In the third, we have to find the a point of inflection. Point of In order to find the point of inflection, we will put second derivative is equal to 0. We have already done this to check the concavity. S coordinate of point of inflection is point of inflection is 2 by 3. This is the point of inflection. At the last, we have to find the graph. This is the graph of the function. If we see that this is the concave upward graph and this is the concave downward. Now let's do another question. Question number 3. F of x is equal to 3x4 minus 4x cubed plus 6. Uh, this is labeled as equation number 1. First of all, we will find the first derivative, which is equal to 12x cubed plus 12x cubed minus 12x square. Second derivative is 36x square minus 24x. And third derivative we have find in this question. Second derivative is, and we will use a third derivative test. F triple prime of x is equal to 72x minus 24. First of all, in order to determine the extrema, we will find first of all critical number f prime of c is equal to 0. If we equate this in equation number 1, we will have 12c cubed minus 12c square is equal to 0. As 12c square is taken outside common and c minus 1 is and inside value is equal to 0, and we will have c is equal to 0 and c is equal to 1. Now we will put in order to check local max or local minima, we will put this in equation number 3. If we put first f double prime of 0 in equation number 3, we will have 0 and the second derivative test fail at this. Now we will takes third derivative test. F triple prime of 0, we will take 72 minus 24 is equal to 48 greater than 0. It means that function has a local max at this point, and this local max can be determined by putting x is equal to 0 in equation number 1, f of 0 is equal to 6. Now we check a second critical number c is equal to 1. We put f double prime of 1 is equal to in equation number 3, 36 minus 24 is equal to 12, which is greater than 0. This means that a function has a local minima at this point, which can be determined by putting c is equal to 1 in equation number 1, and f of 1 is equal to 3 minus 4 plus 6 is equal to 5. Now, in order to check the concavity, we will set second derivative is equal to 0, which is 33 x square minus 24x is equal to 0. 12x is taken outside common, 3x minus 2 is equal to 0, and x is equal to 0 and 2 by 3. With the help of these point, we will construct interval for concavity minus infinity to 0, 0 to 2 by 3, and 2 by 3 to plus infinity. We will check a test value from each interval to check the concavity. We have taken 0 from the first interval. Mm, we cannot take this value. We will take minus 1. Minus 1, uh, and we will put this in uh, second derivative, which is equal to 36x square 36x, and this will be square of minus 1 will be equal to, and this will be equal to 36 plus 24, which is equal to 60. 60, which is greater than 0. This means that function is concave upon this interval. Now we will take a test value from second interval 1 by 2 from interval 0 to 2 by 3, and we put in second derivative f double prime of 1 by 2 is equal to 36, 1 by 4 minus 24 divided by 2 which is equal to 9 minus 12 is equal to minus 3, which is less than 0, which means the function has concave downward in this interval. Now we will check test value from the third interval. We have taken 1 from interval 2 by 3 to infinity, and f2 prime of 1 is equal to 36 minus 24 which is equal to 12. This means that graph of function in this interval will be concave upward. The point of inflection here is uh, x coordinate. At this, if we see this interval in first interval function is concave upward, and second interval function graph as concave downward, which means that 0 is uh, concave a point of inflection. Also, in second interval, the graph of function is concave downward, and third interval function graph is concave upward. It means that 2.2 by 3 is also point of inflection. At last, the graph of this function is like that. Now let's do another question. We have done these questions with the first derivative test. Now we will find extrema of these question using second derivative test. Exercise 19 to 24 use second derivative test to find the local extrema of f on the interval 0 to 2 pi. Sketch the graph of graph we have already studied. We will check the extrema of f. F of x is equal to cos of x plus sine of x. This is labeled as equation number 1. First derivative is equal to minus sine x plus cos x, which is labeled as 2. And second derivative of f is minus cos of x minus sine x is as labeled as 3. The critical number are minus sine c plus cos c is equal to 0, sine c is equal to cos c, and these values are equal when theta is pi by 4 and phi pi by 4. Now we will check the local max or local minima by putting these critical numbers in equation number 3. If we put f x is equal to pi by 4 in second derivative, we have minus cos pi by 4 minus sin pi by 4, which is equal to minus 1 by 2 square root and minus 1 by square root of 2, which after simplification is equal to square root of 2, which is less than 0. It means that function has a local maxima at pi by 4. Local maximum will be determined at the end. Now we'll check second critical number f double prime 5 pi by 4 is equal to minus cos 5 pi by 4 minus sine 5 pi divided by 4, which is equal to cos 5 pi by 4 and sine 5 pi by 4 has values minus 1 divided by square root of 2, which will be uh, after minus minus multiplying will result positive number. After simplification we will get the value of second derivative at 5 x is equal to 5 pi by 4 is equal to square root of 2, which is greater than 0. This means that f has a local minima at 5 pi by 4. Now we will determine the local max and local minimum by putting c is equal to pi by 4 and 5 pi by 4 in equation number 1, which is first is f of pi by 4 after simplification as square root of 2, which is which is local max, local x by second derivative test. And if we put second critical point, which is 5 pi by 4, we will have the local minima, which is we have determined with the help of second derivative test, which is local minima. At the last, the graph of this function. So dear student, study this lecture. I have explained this lecture with uh, minute detail. If you study this critically, you can easily understand the second derivative test and the concept of concavity. To study this, uh, if you have any ambiguity, we will discuss in our online class. Till then, take care of yourself. Allah Hafiz.